Hi guys, today's lesson is on solving exponential equations. So an exponential equation will have a term of the form a to the x. So remember, a is your base and x is your exponent. The exponential equation always has a variable in the exponent. So in order to solve an exponential equation, okay, we are going to use this property right here. So if the bases are the same, okay, that's key. Can I repeat that? The bases must be the same. Then you can set the exponents equal to each other. And then remember, the exponent will have the variable in it, the x, and then you'll solve for x, whatever this equation turns out to be. So I'm going to state it a third time. The bases have got to be the same. So let's take a look at number one. So the first thing we want to do, just like we do with any equation when we solve it, we want to simplify. So simplifying the left side here, we're going to have 2, and then don't forget that when you're multiplying like bases, you do what with the exponents? Correct, you add them. So this simplifies to 2 to the 3 plus x. Okay, then on this side, notice this base is not the same as this base. Remember what I said now for a fourth time. The bases have got to be the same. So we're going to change this to base 2. And 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. So we're going to change this to 2 to the fourth power. That represents 16. So then we're going to take that and raise that to the negative x power. Now, so this is 16 to the negative x power, which is what we have right here. So then we're going to simplify this side over here. We're going to use the rule that says that when you have an exponent raised to an exponent, you multiply. So we're going to have 2 to the 3 plus x equals 2, and then 4 times negative x is negative 4x. Okay, now notice we have the bases the same. So once you get the bases the same, you've simplified it down to this. You set the exponents equal to each other. So 3 plus x equals negative 4x. Now we're going to solve for x. So x equals negative 3/5. Okay, take a look at number 2. So notice all of our bases are different, okay? But before we make these bases the same, we want to simplify so that it looks like this. So we're going to simplify this side. Well, we want to make these bases the same, because remember that when dividing like bases, and those are not like, we subtract the exponents. So we have to make these bases the same. Well, if I try to make them both base 4, well, 4 to the first power is 4. 4 to the second power is 16. I can't get 8 base 4. So I'm going to have to go to a smaller base than 4. So let's try 2. Let's try changing 8 to base 2. So 2 to the first, 2 to the second, 2 to the third. So we're going to use 2 to the third power. That gives us 8 raised to the x squared power. Over 2 to the first, no. 2 to the second, yes. So notice how I just made them both base 2. Again, 2 to the third is 8. 2 squared is 4. Notice my bases are the same. Okay, so I'm going to apply this rule. This would be multiplying. That'd be 3x squared on top. That'd be 2x on the bottom. And when dividing, what do? We subtract. So this is going to simplify to 2 to the 3x squared minus 2x equals 2. So I did 2 steps in one there. I did this little rule here, and then I subtracted that from that. Now that my bases are the same, I'm back up here to this property. And now we can set the exponents equal to each other. So we end up with, let's go back up here, 3x squared minus 2x equals, and then the exponent on this 2 is 1. Now we want to solve this. And you know what? I'm going to go ahead and let you do that because it's quadratic. You should know how to do that. Number 3. And I will be checking when I check video notes for your answer here. Number 3. Now, this one, we have base 3. Now, I want to make this base 3 as well. So, I want to change 27 to base 3. So, 3 to what power is 27? That's right, 3 to the 3rd power. Okay? Now, this doesn't look right. Remember, we want it to look like this. Base equals base. And this is a fraction. So all we really need to do here is move our denominator up to the numerator. So here's an instance, the first time we've seen this, where we're actually going to change the exponent from positive. What happens to it when we move it? Changes, yes. So we're going to have 3 to the x equals 3 to the negative 3rd. Because we moved it from the denominator to the numerator, the exponent changes sign. So now we have bases the same, so we set the exponents equal to each other, and there's no work needs to be done. It's already solved. Okay, moving on. Alright, so we have base 9 here. Can we make this base 9? 9 to the first is 9. 9 to the second is 81, so no. So that means we need to go down a base. So the next number that goes that we can multiply times itself to get 9 is 3. So we know that 3 squared is 9. So we could make this 3 squared. And we know 3 to the 3rd power is 27. So we can go ahead and use base 3 on this one. So 3 squared, okay, that's going to give us 9. So we just changed our base to 3. And that's going to be raised to the x plus 1 power. And over here, we got the square root of 3 cubed. Okay, because 3 cubed is 27. All right, we got our bases the same. Okay, now we're going to do a little simplifying. So exponent to an exponent, so that means we multiply. So we're going to have, remember, we're multiplying a monomial times a binomial, so we have to distribute. And then here we need to change forms, because right now we're in radical forms. So remember how to do that? We write the base. Okay, it's going to be a fractional exponent. The power goes on top. The root, which is square root, goes on the bottom. Now we have it in this format. Now we can set the exponents equal to each other. And then we can solve for x. So why don't you do that? And on the back, we've got some more fun examples. I will let you try number 5. Let's take a look at number 6. Number 6 is a little bit different. Okay, we're subtracting. So when subtracting, we have to have the bases the same. So let's change this to 2 squared raised to the x minus 2 to the x equals 0. Okay, so far so good. Now we're going to multiply because we're raising an exponent to an exponent. Now, can we subtract these two? No, because remember, they're not like terms. So what we want to do is we want to move this one to the other side, because remember, we want it to look like this in order to use this property here. Okay, so move the 2x to the other side. Boy, what happened to me? I'm messing up. That's 2 to the x. Apologize. So subtracting 2 to the x. So we're going to add it to cancel it. Add it to the other side. Okay, so now we have it the way we want it to look. 2x equals x. Subtract x on both sides. So we get x equals 0. All right, last one. So don't let the e throw you off. The e's are the same, so all we have to do is do some simplifying here. So exponent to an exponent, we get e to the 2x equals e to the x squared. So notice the bases are the same, so we can set the exponents equal to each other. And now we solve. So it's quadratic, so we're going to have x squared minus 2x equals, and that's going to be 0. This one's easy to solve just by factoring, so I'm going to factor out an x. And remember that when solving by factoring, we take each factor and set them each equal to 0. So my first factor is x. So there's one solution. Take my second factor, set it equal to 0. And there's my second solution. So there you go. So for you guys, number 5, remember to make the bases the same. And then finish solving number 2. And we'll see you in class. Thanks for watching. Oh, and this is a shout out for Cody Kreider. Don't tell him. Let's see if he actually watches the video and notices that I gave him a shout out, since he's been crying for one for so many weeks.